Hi everyone. My name is Stefan Oehme. I'm one of the Gradle engineers, part of our German team. And today I want to show you one of the latest productivity features that we added in Gradle 3.1, which is Composite Builds. And before we dive into a demo of that cool new feature, I want to explain how we arrived at that and which problem it solves. So who of you uses Gradle? Just raise your hands. Awesome. Some of you might know that our motto is build happiness. And that is not just some fluffy marketing term. We actually think that this can be measured because we're developers ourselves. And we're happy when we're in the flow, when we're solving a challenging problem without being distracted by boring or annoying tasks. So we analyzed what are developers facing every day, what's in their way, what's making them wait, what's taking them out of the flow. And one thing that we identified was that the repository structure that projects have is having a big effect on how developers work. So many of you are probably familiar with these terms, multi-repo and mono-repo. Who's never ever heard of that distinction? Okay, so awesome. I'm going to give you like a short overview. So multi-repo means you have your libraries and applications in separate repositories. They have separate release cycles, probably have separate teams. They might have completely different tool stacks, so they're very isolated from each other. And if you want to integrate them, then you publish to an artifact repository and then pull those dependencies in another project. And that has many advantages and disadvantages. The advantages are you get a lot of isolation by default, so your apps and libraries tend to be a little more modular because you're forced into it. You're forced into modularity. It's also very easy for a new team member to come into one of those relatively small projects and get an overview of what's happening here, what's the structure of the code, what's the build doing, what can I change to fix this bug. It's usually a small, manageable size of code, which also means it's pretty easy to work on it in the IDE. If you have a handful of projects, then every IDE will handle that very easily. The problem comes when you want to integrate these projects. So let's say you want to fix a bug in a library, and that bug only manifests itself in an application that you have. So what do you do? Well, the current state of the art is you check both of them out. You make the change in the library that you think will fix the bug, and then you install it into your local repository. Then you go to your application. You, if necessary, add the local repository to your application. And then you also change the version number of the library to match the thing that you just built locally, because usually they won't match up because the application is probably using an older version of the library than you're currently locally building. And then finally, you can build the app and see, okay, tests are green or tests are red. And when they're red, well, you're going to go through that whole cycle again, build the library, install it into the local repo, and then build your app. Who's gone through this hell? Yeah, we all have. It's annoying, and it's a huge time waster. Another problem is with compatibility. So you build a cool library, and let's say it's version 1.0, and now you want to build 1.1, and your team makes a change, and what they don't know is this change is actually a breaking change for some downstream application. How will we find it out? Current state of the art is you either notice after you've released it and somebody updates the app to use the new version, they tell you, oh, hey, you just broke us. So please do a patch release and tell everybody that this version is bad. Or, which is arguably even worse, you force everyone to use snapshot versions. So all the builds are non-reproducible by default. And these problems have led people into another extreme, which is the mono-repo. Led by the example of Google, mostly. So some of you might know how Google works. They have a huge repository that contains all their code, all the libraries they've ever used, and even all their build tools and everything. It's all one big repository, and everything is built from master. And that has some charming advantages. There is no versioning issue. Like, everything is in the same source tree, so when you change a library, you immediately see the impact. You just say, okay, Gradle build, and you see, oh, I broke my application because it's in the same build. You also don't need to worry about artifact repositories or anything like that. But it comes at a price. It comes at a price in performance. So when you do a build, you don't just build what you're interested in, you're also building everything else. And even if it's up to date, you're still paying for the up-to-date checks at least. And you're paying for the configuration time of those projects that you're not really interested in. It's also a usability issue. If you import such a large project into the IDE, at some point you hit the scaling limits of the indexers of IntelliJ and Eclipse. And it's also just a discoverability issue. It's very hard to find your way around a code base with, let's say, 1,000 modules. And then there's also the problem of creeping dependencies between those modules. If there's no repository boundaries, no clear version boundaries forcing you into modularity, it's very easy to go back to just tangling everything together. So it has some big disadvantages too. And this is why we wanted to find a solution that allows you to get the benefits of both. And that's why we built Composite Builds. Now, Composite Builds, very simple, allows you to combine multiple independent Gradle builds into one big one. And that means you can take your library and your application and combine them into one big build and say, hey, just run all the tests with these two together. And what Gradle will do is it will determine that, oh, this dependency that my application has, this org, my company, my utils, is actually provided by this other build that's also in the composite, so I'm going to use a project dependency instead. So with one command, you can just say Gradle build, and it'll first compile the library, and then the application. And once you make a change in that library, the application build will immediately pick it up, and you'll know if you've broken something or not. So this gives you like really quick local experimentation. You could import that into your IDE and do cross-repository refactoring. It also allows you to move from, let's say, a monolith to a multi-repo build. So you have your big build, and you want to bust it up into smaller pieces. And it's much easier if you first start out saying, okay, let's keep everything in one repository, but let's split this big build up into smaller builds. They still live in the same repo, but they're more isolated. We're actually forcing ourselves to make it so that we can build each piece alone and together. And once you have that, you can then go and say, okay, let's take this one build, take it out of the monolith, put it in its own repository, publish it, and use a binary dependency instead. So it's a very smooth migration path away from monolith if you need that. And another use case that I personally love is plugin prototyping. So who of you has built Gradle plugins before? I'm very proud of you guys. Very productive crowd here. So when you build a Gradle plugin, of course, you write lots of automated tests, which is great, so you get fast feedback if you broke something. But in the end, you often just want to do some quick experimentation. You want to write an example project and try out the latest version of your plugin. And with Composite Builds, you can finally do that. So you can take the latest version of your plugin, you can take the example, put them together into one build, and run the example build, and it will immediately pick up any changes in your plugin. So let's see how that works. So I have here 3 applications. The first one is the very simple example that I talked about earlier. I have an app and I have a library. So I'm going to go into that example. And now I have a dependency in my application that says, I depend on org sample number utils and org sample string utils. And these are provided by the myutils project. So imagine you have checked both of them out into your Git repository, and now you want to fix some bug in that library while testing it against that application. And what you can do now is say, Gradle, include this other build called myutils, and run the application. And you'll see that I'm not just compiling my application, I'm also compiling the library. And I get an answer that I'm not expecting, which is -4, because if we look in my application, what I was actually doing is printing numbers at 1923, so that doesn't match up. So let's go into our number utils and fix it up. Yeah, simple mistake. Replace that with a plus and say run again, and there we go. Our bug is fixed, and without any publishing to a local repository, with any pain, I just immediately could see the result in my application. Now, you'll see when I say Gradle, give me the compile dependencies, that our dependency to number utils, I should say offline, that my dependency to the number utils library was actually replaced with a project dependency. And similarly, the other string utils library was replaced with a project dependency to the project in my number utils build. And this is not just some dumb replacement, so we're not just taking that one dependency and replacing it with the project, we're replacing the whole graph. So if I were to go into my string utils build and, for instance, change its transitive dependencies, we have a dependency on commons lang here, if I change that, it would also be picked up by my app. So any change I make to that other build is immediately picked up. Conflict resolution works. Everything is just as if those two were always together. Now, after a while, it could become a little tedious to say include build, include build, include build, right? So what you can do is you can make this persistent. This is what I've done in this composite project. So this is a project that just lives next to the other two, and it has a settings.gradle file that says include my app and include my utils. So if I go into that project and say Gradle run, I don't need to do any include build anymore, and you can see both my app and my utils are built, and I get my answer. So you can imagine this way you could, for instance, have a composite that just iterates over a folder, for instance, your Git folder, and just includes every Gradle build that's in there. It just says, hey, I want to include all of them and see if everything still builds together. Or I want to import all of them into my IDE and do cross-repository refactoring. And this immediately leads to another use case that you can do very similarly, which is when you have a monorepo and you want to break it up. So I've taken the same example, called it the monorepo app, and this time, instead of these projects being independent and living next to each other, I've actually nested them. So I have my application, and it contains number utils and string utils as independent builds inside one repository. And what I've done here is actually, for my colleagues' convenience, I've made this a for loop. I've said, for any folder that's in the modules directory, include as a Gradle build. So my colleagues no longer need to worry about the settings configuration. They just add more modules to that monorepo, and it'll just work together. So let's step in there and see how that application works. So let's just say Gradle run. We should get the same result again. We're having number utils, string utils, and my main application. And when I say Gradle dependencies for the compile configuration, you'll see that these dependencies are replaced. But I could also CD into one of the smaller builds down there into number utils and build it alone. So when I'm just working on number utils, imagine it's a relatively big build in itself, I can import just that into IntelliJ, for instance, work on it, make some changes, run some tests, without building everything else, like my whole other app or all the other libraries that I have. And now we want to bust up our monorepo. We actually want to move number utils into its own repository, and we want to go towards binary dependencies. I've added a simple task that simulates this by publishing to a local file repository, so I'm just going to call that one, say Gradle, publish these two libraries to a local repository, and then we're going to move number utils somewhere else. So literally somewhere else. And then run our build again. Look at the dependencies, and you'll see that string utils is still replaced by that project dependency we had before, and number utils is now taken from my binary repository. So it's that easy to switch between local or binary integration. And you could, for instance, also combine it with Git submodules. Make it convenient for your colleagues to check out a number of other projects that they might want to work with locally, but if they're not there, just use the deployed version instead. So the difference between an included project and an included build becomes very fluent. And my favorite use case, as I said, is the plugin development. So I have a little greeting plugin here. It's very simple. It just says hello. And I have someone that uses this. So I say, I depend on the greeting plugin 1.0. I apply it, and I create a greeting task that says greet Bob. And I have my plugin next to it. And now I want to make a change to my plugin, and I want to see the result on my build immediately. So let's go there. And say Gradle greet Bob. And we'll see, okay, our plugin is built before the rest of my build is executed, and then our greet Bob task is called. And if I now go into my plugin and say, hey, I don't like that greeting, I want to change it to hello, and also get rid of these exclamation marks. And I can immediately see the effect on my build. So this allows you to really rapidly prototype a DSL for your plugin, see how task up-to-date checking works, etc., using an example build, and then maybe using this example build as a basis for your test cases that you'll write later. So this is in Gradle 3.1. You can already use it. It's stable. And you could use it for even other things than just local development. For instance, one of the things I talked about is it's very hard to find out if a library change breaks downstream applications. Basically, the only way currently is to use snapshots, which is a problem in itself. So what you could do with Composite Builds is you can have a CI job that takes some of your libraries in your application, puts them into a composite, and then runs the check task and says, hey, do these all work together still? Because by default, Composite Builds will not take the version number into account. So as long as group and artifact ID match up, the dependencies will be replaced. You can customize that, of course. So you could customize it to use semantic versioning and only replace it if you think it's compatible. But the default behavior should suit most of you, I think. And so this way, you can give your library authors really fast feedback. They commit, make a change. Nobody else is yet using it, but they immediately get a message from the CI server saying, hey, you broke that application that we have. You need to fix this library before you release it. There are some limitations currently, some of which we've already addressed. So the biggest limitation in Gradle 3.1 was the missing IDE support. You couldn't import composites into Buildship or IntelliJ. This has been fixed in Gradle 3.3, which is going to go out in mid-December. You currently cannot target tasks in included builds. So when I have a root build and I include the my app and my utils, I can target tasks in the root build, but I cannot say my utils build from the command line. This is a feature that we'll add in the future, definitely. And we will also make it easier to target a subtree. So let's say I want to run the build task in all subprojects of my app. And this will benefit composites. It will also benefit normal multi-project builds. I think, who has had that use case that they just want to build a subtree of their project? Yeah. So currently, the solution, which is not really nice, is to either cd into that subtree or use the -p switch to select the project directory. But this is kind of awkward. It requires you to drop down to the physical structure of your project, whereas we really want to talk about the logical structure. So we want to talk about project names and task names. So there's going to be kind of a wildcard syntax where we say, build everything that's called jar below this project. We currently cannot substitute custom publications. So if your library has, let's say, a main jar and a test jar, we currently only can substitute that main jar. Can't depend on a test jar in the composite yet. This is also something that we will improve. So the dependency substitution API will become more powerful to support custom publications. The included builds aren't built in parallel at the moment. It's kind of an obvious improvement, but still needs test coverage, of course, and still needs some thought. So we haven't gotten around to that, but it is an obvious improvement that we will do. Continuous build currently won't detect changes in included builds. So we will warn you if you use continuous build together with composites and tell you like, hey, this might not work exactly as you expect. So this automatic change detection and rebuild that you are used to from continuous build will not work for included builds at the moment. There is also currently no support for nested composites, so composites of composites. This is also a natural extension of the concept. Take the monorepo example. You have a big monorepo, you split it into a few builds, and then these builds are still a little too big. Maybe you have 1,000 modules and you want to have 2 levels or even 3 levels of nesting to get like really small pieces that individual teams can develop. So this is also something that we're going to address. And at the moment, all builds will be built with the same Gradle version. So what you saw, I said Gradle build in the root project and the root build, and all the included builds will be a sub-build of that. So they will be executed in the same daemon with the same context as the root build. So you cannot have mixed Gradle versions at the moment. This is something that's, I would say, a little further down the road. I think having everything use the same version is probably the 80-20 solution. There might be use cases where you want to have projects that are just completely incompatible version-wise, but it's not on our priorities right now. And last but not least, there is currently no support for producing build scans for composite builds. This is mainly because we need to come up with a good UI metaphor, because composite builds are builds which contain other builds. So we need to come up with a good way to visualize that. So here's the tasks that were executed, and then there was a whole build that was executed. So nothing we can solve on this list, but some limitations to keep in mind while you use this feature. Now, as I said, IDE support is solved on the master branch. So we added support for composite builds to the tooling API, and this will be released mid-December. Buildship 2.0 already has nightly builds and soon a milestone build that you'll be able to use. So if you're an Eclipse user, you'll be able to import composites if you use the Buildship milestone and the latest Gradle nightlies. IntelliJ IDEA already started some basic integration that is in the 2016.3 early access program, so you can check that out. And full integration with Gradle 3.3 so that you can import composites defined in a settings.gradle file will come in 2017.1. So keep an eye out for that. There should be some early access versions coming up soon there. So let's have a quick look at how working with the IDE work with a composite. So I'm using Buildship here, which is the Gradle Eclipse plugin that we develop ourselves. and I'm going to import the plugin development example. And you can see I'm pointing Gradle to that consumer project, which had an include build statement to include the plugin itself. And the consumer project, as well as the greeting plugin, are imported into BuildShip. And I can run tasks in the consumer, so I can say, hey, greet Bob, and I get hello Bob. Now I can go into my plugin in the same workspace, make a change it to hi, rerun the task, and get an up-to-date result. And the same works for libraries. So I could import that application and library example, refactor them across repository boundaries. I could take the monorepo example and just import one of the parts of that monorepo, just work on that as if it was a completely isolated build. Or import the whole monorepo to make some big sweeping change if I'm the architect of that project and have that kind of power to make these decisions. So the repository structure no longer determines how you work. All right, and the other thing that I mentioned is build scan support. So who of you has heard of build scans already? All right, so build scans are a way for you to get more insight into your build, and this is why it's really important for us to also support that for composites. It allows you, it takes all the things that happened inside your build, like the tasks that were executed, how long they took, which dependencies were resolved, how long that took, which plugins were used, which Gradle version, which platform you build on, and so on, and makes that available to you as the build master by uploading it to a central server. So you see all the CI builds, all your local developer builds, everything that happened in your organization, and you can analyze that and make decisions. For instance, you see, oh, my developers are calling clean all the time. That shouldn't be necessary. Gradle has great incremental build support. So you could get in touch with them and say, hey, why are you using clean all the time? And they will tell you, well, there's this one task that doesn't work with incremental build. And you wouldn't have found that out otherwise. And then you can fix it, and they are more productive. Or maybe you see, oh, that task takes like 10 minutes, and everybody's waiting for that every morning. It's a huge productivity waste. Let's make that one task more efficient, and we'll save a bunch of money. And also it helps your developers get feedback. So they have a problem, and what usually happens, well, they write you an email or they call you up and say, well, it doesn't work. Okay, can you give me the stack trace? Then you get the stack trace. Okay, which system are you on? And which Java version do you use? And which switches did you use? And so on. So that goes back and forth, probably for hours, until you finally find a problem. With a build scan, you can just tell the developer, give me the URL of your build scan. And you can have a look at everything that was happening in their build and tell them, oh yeah, you're using the wrong Java version. And then maybe add a check to your build that makes sure this doesn't happen again. So if you want to see that in action, you can stop by at the Gradle booth or just go to gradle.com and check it out yourself. There's a free public version of it, so you can use that for your open source libraries and produce build scans for those, try it out. And of course, if you have any other questions, I will be there, and some of my colleagues will be there at the Gradle booth to answer your questions, show you more about the latest Gradle features and Gradle Enterprise if you want. And of course, after this conference, you can always go to gradle.org, ask questions in the forum. We have a big community, as you probably know, that is very helpful and will answer all your questions. And with that, I would like to get your questions now. Please.
There used to be a very nice way to prototype plugins using build src directory. Any obvious reasons or comparison with the composite build?
Okay, so the question is, how does composite or prototyping plugins with composites relate to the build source project that we already have? The build source project will probably become an implicit included build as soon as we support nested composites. So basically, we're just going to get rid of this concept of there's this one magic folder that works like a composite, and instead you are much more flexible. You don't need to put it in build source. You don't need to put it inside the same project. You can put it in its own repository and then connect them to prototype when you want to. So you don't need to, like, many users have been doing that. They've been copy-pasting stuff into build source to prototype it and then copy-paste this, the fixed solution back into the real plugin. So you're basically getting rid of that. You're welcome. Any more questions? Go ahead.
Controlling the state of the included build, you named Git submodules. Is that the only way how I can specify which version of the other project I want to build?
Okay, so the question is, are Git submodules the only way to include builds? No, that was just an example. So.
No, I'm asking about how can I control the version that gets built?
It's the one you checked out, so the one you have locally. You could, of course, build something that finds the correct repository branch and checks that out for you. But the way it works is currently either you have a monorepo, so like several builds in one repository, or you have some kind of other orchestration, like you checking out projects locally, or your build server checking out a bunch of projects next to each other and then making a composite out of them.
Yeah, that's the question. So the build server has to know which.
Yes. So one of the next logical steps would be taking the knowledge that build scans have about how your projects connect together and feeding that back into the build server and saying, hey, I've built this library, now build all the dependents with this library together. So making build servers smarter. All right, so for any more questions, you can find me at the booth. I'll be there all day and tomorrow and Thursday too. Thank you.